This is the last video, so welcome to the last video unless requested or I receive other request for more. So this is the last content. Trees, say hello to my Hebrew handwriting. Trees and graphs. Just imagine I'm writing graphs. So trees and graphs, that's the part we're going to do today. Almost no coding. It's more theoretical than coding, so let's jump right to it. First we'll be talking about trees. Okay, let me show you something. So prefix, so you take the left 5, then you go to your head, which is plus, and then you look at your right, which is 3, and then you go to your upper class, which is star, and then you look at the right of your upper class, which is 8. That is 5 plus 3 star 8, which can also be written as plus 5 3 8, which is this tree actually. So if you convert this to this, then you get this. That's a primary introduction to trees. It's made up of nodes, edges, or rings. So there are many types of trees. Free trees, no structure, nothing, just a set of nodes, no sequencing, no, what should I say, discipline, stuff like that. Rooted trees, trees with roots. A distinguished knot, maybe it has, for example, rooted trees could be plants. Imagine I'm writing plants. It could lead to fruits. Imagine that I'm writing fruits, and it could lead to flowers. Once again, you have to use your imagination. So fruit, this is the root plants, and then you have to fruits to flowers, and maybe you'll move on to rose, China flower, and here you can move on to jackfruit, berries, strawberries. That's how this tree continues. Then you have ordered trees, which has a specific order, and then married trees. We'll talk about this. So like I mentioned, it could be an ancestor, descendants, and sibling, parent, grandparent, grandchildren. And one more thing about trees, that it may have end of, for example, if you have L, S, T, S, O, and T has PQ. Since T has 2, S doesn't need it's not obligated for S to have another. So S can have an empty place and an O. Though my Hebrew handwriting suggests that both of them are empty, but this is actually O. I know it's hard to believe, but this is O. So S doesn't have 2, unlike T, which has 2. So there is not that much of the order, you see. So that's for rooted trees. Ordered trees. Ordered trees have a good order. So it's not explained much over here, so let's just skip that. Married trees, which is important. Every single node must have equal number of children. So if S and T, let's bring them back. If T has P and Q, then S must also take 2 children. It could be MN. So 2 for T, 2 for S. That's the idea of married trees. Okay? And binary trees suggest that it should be ordered. See, a binary tree must be sorted actually, just like the binary search. It has to be ordered, it has to be rooted, and then those trees are free. So we'll see the methods, how they're formed. Let me bring out my pencil. So look at this one. Node will be the head. So let's consider n 1, 2, 3, 4, 5, 6. Okay. Not left, not right. So this is left, this is right. Again, if this is the head, this is left, this is right. Again, if this is the head, this is left, this is right. So this structure applies for this, also for this, and if tree has further children, then this also applies for this. Okay? And it also has an item. Okay. Now we're getting a parent. So it could be like this. So let me show you. N A B C D. The for A, consider we are considering A. Left would be C. Right would be D. Parent would be N. So that's how A is. It has C on the left, D on the right, and N as the parent. So I think you know the structure now. Now we'll do graphs. Here we'll find out how the trees work actually. So let's get straight to it. Pay attention guys over here. This is something that will appear on your exams. You have three types of traversal: pre-order, in-order, and post-order. So for pre-order, you have to visit yourself first, then the left, then the right. So let me draw something. N S T Q R. So if you're doing pre-order, visit self. Who's self over here? If you're not understanding, okay, let me show you with a code example. Look at over here. Now let me draw it again. N T S Q R. Node N. I'm sending N over here. If N is equal to null, then return. If it has nothing, for example, let's take P, which has nothing. If I send P over here, it has nothing, then return nothing. So this tree is empty. But if I send N, visit self, then left and right. So who's self after N? N. Then visit left. Who's self? T. Visit S. Is there any self? Sorry, is there any left and right over here? No. Then this is the last self. So you have T. You already had N though. N, which is the first self. Then you have T. Then left, which is S, and right. And then this right. Sorry. Come on. Oh man. I won't use the letters R, and I already used it. Oh, pathetic. Q. Did I just write R twice? Okay, so you have N, which is the self. Then you have to visit left. Okay, this is the left. Then you have another self, T. So you have to visit T. Then you have the left R, and you have right B. And remember this self, you visited left. Now you have to visit right, which is Q. That's pre-order. In order. Okay. For in order, you have to visit the leftmost, then the right, then self, and then right. So N, T, Q, R, S, T, I already used it, so F, B. So visit the leftmost. Is N the leftmost? No. Is T the leftmost? No. R. Then visit self, T. Then visit right, S. So left is complete. Now visit right, self, N. Is this the leftmost? No. B. Q, self, and then finally F. So that's in order. And now you have left, right, self. So let's try another one. Leftmost, S again, then right, Q. Then you have F and then P. Then right, R. And then F and N. Oh, after S, Q, you have T over here. So that's your serial. First the left, then the right, and then the visit. So let's have a revision. For pre-order, you need to visit self, then left, then right. This is pre-order again. For post-order, you need to visit, so in order. Pre-order visit of left, that means the leftmost, the most leftest one, the leftest one, that is. Leftest, visit self, and then the rightest one. And for post-order, you have pre-order visit, use pre-order visit of left, pre-order visit of right, and then visit self. It would be better if we had some examples, and maybe we don't have any over here. So binary search trees, these trees have to be sorted. This is an important method. Find leftmost. If n.left is not equal to null, then return n, then find leftmost, keep going to the left, to the left, to the left, to the left. And this is where the method is returned. Similarly, you can find the rightmost. See over here. Nothing much to show you over here. This is how binary search trees work. You can understand it using those nodes. And then we have graphs. Okay. Some things over here. Directed graphs. For example, look at this one. No one is directed to anyone. So this is an undirected graph. Here you can see there are directions. For example, G goes to I, E goes to I goes to H. There are specific directions. So this is a directed graph. And this is an undirected graph. Okay, so you have to find the shortest value or something using this. That's a separate topic. You probably won't have it. You will have it in CSE 230 though. Consider A. Does A have any connection to self? Obviously not. Does A have a connection with B? Yes, it's going to B. So you put 1 over here, which is this. Is A going to C? No, 0. Is A going to D? Yes, 1, which is this. Is A going to E? No. Done for A. B. B is going to C and E. It doesn't matter who's coming to B. So D is still 0. A is also 0. It only matters whom B is going to, C and E. So you have 1 on C and 1 on E. None for B. C goes to none. So it's complete 0. Poor little guy. D goes to E only. Oh, D also goes to B. So D and E. That's for D. E goes to C. At least it goes to someone. So it's 1 on C. So the modest value is C, and anybody else is going to someone. That's how you create an adjacency matrix. Okay? And if there are no specific directions, then you just set up all the connections. So for A, you have B and D. For B, you have A, B, C, D, E. Hey, almost all except B itself. For C, you have B and E. The poor little guy finally got someone. For E, you have C, B, D. So C, B, D. C, B, D. For D, you have A, B, and E. So A, B, and E. Much easier for undirected graphs. Now, this is something else though. Okay. Traversal. Hash tables, that's not for us. So I guess that's the end, more or less. I don't think you will have graph traversal and stuff like that, but if the syllabus changes and something happens, we'll be working on it. We'll make new videos on this, and I hope if you have any problems or you have other topics, please let me know in the comments below, and I'll try to come up with another video doing the traversals or stuff like that, if they appear, that is. So until that, this is the last video for CSE 220, where you did graphs and trees and 2 traversals, which was theoretical. Example, I have example, and this is the correct one for sure. Okay, pre-order. Let's do pre-order. You will visit self, then pre-order of the left, which is once again self, and then left, self, then left, self, no more left. So right, A, B, D, H, A, B, D, H. So far we are cool, but this has no left, so now you'll go to right, which is I. Okay, right, and then who's right at E? This one. And then right one is C, but first self, so after you have C. Left, F. Any left, right? No, so right, G. Self, and then the left, J. Pre-order was, as I told you, every time we didn't make any mistake in pre-order, but probably I messed up in order and post order. So let's see that. For in order, you have to visit the leftmost, so no doubt you will start. Like I said, the first one I told you was the correct one, so you start with H. Clear. In order, we're doing in order now. You start with H, the leftmost. Any more left? No. Then you visit the self, so that's D, and then right. Now D is the leftmost of this, So you visit B and then right, and B is the leftmost of this, so you visit B, A, and then right. So let's see, we have H, the leftmost, and then self, and then the right. Then we have B, which is the left self of this, and then the right. So HD, B, HD, I, B, E. So far so good. Then this is the self of B, so A, and then this is the right, but we have to visit the leftmost first, so we cannot go here, we have to go here first, so F, and then you can visit C, self, and then the right, but this right has a left, so I cannot visit him now, I have to visit J first, and then I will visit G, which is self, and there was something over here which is H, then I would have, oh, it's already there, W, then I would have visited W. So the left one first, left one first, left one first, left one first, and left one first. That's the thing. Left, self, right. That's what we have to remember. And pre-order, self, left, right. That's pre-order. Self first. And for in order, you have left first, then self, then right. Now post order, left, right, self. So left, the theory of left is same, so you have H. But for when in order, you visited self, so it was, let me write L, S, R, left, self, right. But this time it is LRS. So if it was LSR, then it would be HDI. But no, this is LRS, so HID. So that's HID. Okay. HID. So far so good. Left, self, R. So D, E, B, which you can see over here, EB. Okay. Now left, self, R. So B, R, C. But for C, I have a left. So F, then I would go to C. But I have a right. So G. Then again I have a left. So this L. So after this, F. Oh, I should label them clearly. Now we are here. Left, self, R. So I visited B. Okay. Then I have this C on right, but it has a left. So again this become S1, L1, R1. So I have to visit L1 first. So F. And then I visit R1. But then again this has a left. So I have to visit J. And then there is any right? No. So self, which is G. Any more right? No. So now self, which is C. Any more right? No. Now A. So H, I, D, E, B, F, C, G, J, G, C, A. That's post order. For the last time, pre-order is self, left, right. Post in order is left, self, right. Post order is L, left, right, self. Okay, so it's always left, left, left. You won't have any order which starts with R. Okay, so sorry for the interruption. I did it okay in the beginning, but then I had a feeling that I'm doing wrong, but I was actually right. So now it's confirmed, it's right. This is how you do tree traversal. So with that, let's end this. I hope you won't have any problem with traversal anymore with this example. This is pretty good as an example. So that's all for you. today, folks, and maybe that's the last video of 220. So until next time, in any other course, see ya, and keep surviving. All you need to do is survive.